Hello class, today we are talking about section 8.1, which is reasoning and counterexamples. By the end of today's lesson, you will be able to identify hypotheses and conclusions. You will be able to write statements in if, then, or conditional format. And you will be able to use counterexamples. A conditional statement is written in the format of if something, then something. So it's a simple if-then statement. The hypothesis is the if part of the statement, so that first clause that you have. The conclusion is the second part or the result of that statement, so the then part of the statement. So if we are looking at if it is the 4th of July, then there will be fireworks. Your hypothesis is it's the 4th of July. That's the if part of the statement. The conclusion is there are fireworks. That's the then part of the statement. Same thing works with mathematical examples. They can be written in if-then format. If 2x plus 10 is equal to 20, then x is equal to 5. Your hypothesis is the equation part. 2x plus 10 is equal to 20. And your conclusion is that x has to equal 5, because x is the solution to the equation. Other things that we have to be able to do with this is to be able to rewrite statements that are not in conditional format and then be able to identify our hypothesis and conclusion. So for example, Ellen drinks Gatorade when she finishes a race. We want to look to figure out which part of this is certain. So we know that Ellen drinks a Gatorade when she finishes a race. Do we know that that is the only time that she drinks a Gatorade? No, but we can say for certain that if she has finished, she will be drinking a Gatorade. So this part at the end is actually our hypothesis. So if she finishes a race, then Ellen drinks Gatorade. So the first part, the if she finishes, is our hypothesis, and the drinks Gatorade is our conclusion. We are certain that if she finishes the race, then she will drink Gatorade. We can't guarantee that that it's the other way around. Second example we have, for the equation 3y plus 4 equals 25, y equals 7. Again, we want to pick out the part of the equation that's the hypothesis and the conclusion, so we can rewrite that sentence first. So we're going to say if 3y plus 4 is equal to 25, then y is equal to 7. That first part, again, is our hypothesis, and the second part is our conclusion. We can't flip this around to say if y equals 7, then 3y plus 4 is equal to 25, because that's not the only equation where we could have an answer of y is equal to 7. We could say y plus 1 is equal to 8. Y would also equal 7 there. So we can't use y equals 7 as our hypothesis because the conclusion of 3y plus 4 would not necessarily have to be true. So go ahead, take a minute to rewrite this sentence into a conditional if-then statement, and then identify the hypothesis and the conclusion. So you should have rewritten it to, if it is summer, then there is no school. The hypothesis being that it's summer, conclusion being that there is no school. The other thing we have to talk about today is the counterexample. This is a specific case where the hypothesis is true, but the conclusion statement is false. So the if part is true, the then part is false. So for a mathematical example, we have if A plus B is greater than C, then B has to be greater than C. So if they're asking you a question like this, your job is to pick out 3 numbers, one for A, one for B, and one for C, that makes this part of the statement true and this part of the statement false. So I'm going to pick that A is equal to 7, B is equal to 1, and C is equal to 2. So then I have to double check. 7 plus 1 is greater than 2. 8 is in fact greater than 2. So our first part of the statement is true. The second part says that B is greater than C. That's false. So that proves that this whole statement is not actually a true statement. So if A plus B is greater than C, then B has to be greater than C is not a true statement. We found our counterexample with numbers that make that untrue. Second example is a logical sentence. If it is Monday, then we have school. So this is saying that every Monday in the whole year we have school. There are a lot of different ways that you could prove this wrong. 1, you could say it's Labor Day. Labor Day always falls on the first Monday of September. We don't have school on that day. So that proves that it is Monday because it's Labor Day, but we don't have school. So that makes the second part false. Another thing you could say is it's a Monday in June. We don't necessarily have school on Mondays in June. We might have it on the first Monday of June, but we won't have it on the second or third Monday of June. So again, it's true that it's a Monday, but it's false that we are in school. So go ahead and try this one on your own, making sure you are picking out a value for A, a value for B, and a value for C. This is just one example of an A, B, and C list that would work for this example. A is 5, B is 4, C is 10. 5 times 4 is 20, which is greater than 10, but our conclusion that 4 is greater than 10 is false, so we have a counterexample. If you have questions about this or any other part of the lesson, please let me know when you get to class.